Hi guys, last week we had a twofer. We talked about air pollution and the ozone hole. In our discussion of air pollution, we started off talking about the history of air pollution and its evolution over time before focusing on the long-range transboundary air pollution agreement. We drew some lessons from the long-range transboundary air pollution agreement for contemporary air pollution issues, and then talked about the challenge of addressing the ozone hole, why it was the most successful international environmental agreement that the world has ever developed, and it helps us understand the nature of the ozone problem relative to the topic we'll talk about next week, which is climate change. We started off our discussion of air pollution looking at the historian John McNeill's book, Something New Under the Sun, and traced the evolution of air pollution impacts by humans over time. The story is one of mostly localized impacts with the invention of fire and early industry, that you had smoke and air pollution billowing from a local level and potentially affecting the surrounding neighbors. But over time, as the Industrial Revolution took off, you had the capacity for air pollution from industry to drift further afield. So by the 20th century, you have not only considerable urban pollution that affects large geographic landscapes, but you also have the ability for that pollution to spread transnationally across borders with the prevailing winds. And you see problems like acid rain emerging. By the late 20th century, you see the capacity of humanity to, through the ozone depletion problem and through climate change, for there to be planetary impacts of air pollution. One of the regional air pollution problems that we discussed was the problem of acid rain in Europe. This was a problem in the 1970s and 1980s, where you had forests die off, and also impacts on fisheries and agriculture from the acidification of rain wrought by the combination of sulfur oxides, nitrogen oxides, volatile organic compounds, mostly from the burning of coal that blew across Europe, emanating particularly from England, but also continental Europe, and led to significant forest impacts in Scandinavia. So this has elements of both an upstream-downstream problem, in which the perpetrators and victims are different, in which the perpetrators in England are victimizing countries in Scandinavia. But given that there's considerable self-pollution from this problem, in which the perpetrators of air pollution are also victimized by the impacts, that it also has attributes of a commons, of an area that can only sustain a limited amount of pollution, but from which it's difficult to exclude actors from polluting into. So we also talked about the long-range transboundary air pollution agreement associated with this problem, which for which there was a framework agreement in 1979 and a subsequent series of protocols in 85, 1988, 1991, which added more chemicals and different approaches later on, starting out with sulfur dioxides, moving to nitrogen oxides, then to volatile organic compounds. And we read Mark Levy's article, which tried to assess what effect this treaty arrangement had on emissions and whether it was successful or not. As backstory to this assessment of success, Levy noted that there were divisions between countries like Sweden and Norway that were really enthusiastic out in front of wanting to see there to be controls on these emissions, with other countries like England and Germany more recalcitrant, at least at the outset, with Germany later switching sides given changes in its domestic politics and rising awareness about its own self-pollution, and then England ultimately acquiescing in part because of the wider political pressure from other actors, but also its own conversion from coal to natural gas. This long-range transboundary air pollution agreement was also bound up in the wider high politics of the time, with this solution being embedded in a wider effort to foster good relations between, or at least better relations between Europe and the Soviet bloc, where they were looking for an area of potential cooperation that could diminish tensions between these regional neighbors. The 1985 Helsinki Protocol established emissions reductions targets for signatories and the countries that were party to the agreement of 30% reduction by 1993 below 1980 levels. But there weren't any strong punishment mechanisms associated with this other than the visibility of countries for failure to live up to their commitments. It was a form of what Levy described as tote board diplomacy, in which countries could get credit for getting on the scoreboard and showing what they were able to do to achieve their emissions targets. And it had some utility in exposing those that were in good standing and able to get on the scoreboard, and those that were not. Levy and others who evaluate the success of the long-range transboundary air pollution agreement ask the counterfactual of what would have happened without the agreement, and also did some countries' behavior change to be consistent with the agreement, but not because of the agreement. And so Levy has a table in the article which shows that some countries, particularly in Southern Europe and the Eastern Bloc, did not change their behavior at all. Some countries in Scandinavia, for example, reduced their emissions, but that was what they were prepared to do anyway. And then some countries maybe changed their trajectories because of the availability of science, which perhaps helped them understand their own interests better. In Germany's case, they had their own scientific understanding, which helped persuade them that they were receiving considerable self-pollution from acid rain. And in other countries' cases like Austria, Finland, the Netherlands, and Switzerland, that the science convened by the agreement helped them have a better understanding of their interests and act in accordance with the agreement. And then there were other countries like England, maybe the Soviet Union, possibly Denmark, who for wider political reasons changed their behavior, not necessarily because of the science, but because it was bound up in the wider tensions of the time. There are several implications of the long-range transboundary air pollution agreement for other policy areas. First, if there's significant self-pollution, we can see that there are strong incentives for a country to want to reduce its emissions, and we saw that in the case of Germany. We also saw that issue linkage worked for some countries. So the UK at the time was embedded in the wider European Union and sensitive to the pressure from other EU member states. And the Soviet Union sought to improve its relations with countries in Europe as part of broader East-West thaw, and was therefore open to reducing its emissions as part of that wider effort to reduce tensions. We also saw the role of science in that some countries like Austria reappraised or came to understand their own interests a little better through the science that was generated through the process. We also saw that some countries complied with the treaty, not because of the treaty per se, but for other reasons. And again, In the case of the UK, they were able to make the transition from coal to gas, which also helped their ability to reduce their emissions of air pollutants. Finally, in keeping with the idea of tote board diplomacy, leaders may set goals and policies to get credit, to keep score, if you will, on the international stage, and that, even in the absence of compliance mechanisms, can push states to reduce their emissions. The current high levels of air pollution in different country contexts like India and Pakistan has historical antecedents, and we discussed the case of London in the 1950s, in which for several days the city was blanketed with dangerous smog that led to the deaths of several thousand people. And the fact that those countries and cities like the UK and London experienced high levels of air pollution in the past and have been able to make considerable progress leads Hannah Ritchie to be quite an optimist, and she suggests that the experience of those other countries suggests that it's only a matter of time for countries like India and Pakistan to come to grips with their problems, which have a variety of sources, as we discussed in class, but there are technical solutions that can facilitate dealing with high levels of air pollution around the world. What I find remarkable, though, is that despite Indian citizens losing several years off their life expectancy due to air pollution, that the issue has not yet been politicized at the level that one might expect. And that raises interesting questions about why that's the case. And we dealt with that to a certain extent in our discussion of some of the news articles from last week, but I don't think there's a strong definitive answer yet. And maybe it is only a matter of time, but it will matter for millions how soon the Indian electorate ultimately decides that this is an important enough problem compared to other issues that they care about, like economic growth. And maybe this concern about environmental protection is subject to the so-called environmental Kuznets curve, that at certain levels of wealth that the country will transition from being primarily concerned about economic growth to increasingly being concerned about other attributes like life expectancy, but we shall see. That hasn't happened yet. And the other issue is that some of this pollution is of a trans-border character, and is there a regional solution in places like South Asia for this problem set, given that polities in the region have pretty difficult relations with each other? Is there a need for cross-border collaboration to address air pollution? There's probably a need, but there are broad political barriers to doing so. But this is a watch this space moment. The last topic we discussed this week was the ozone depletion problem, which was discovered in the 1970s and was associated with the increased use of propellants, of chlorofluorocarbons, which were used in refrigerants and hairsprays, and were degrading the protective layer in the stratosphere of the ozone layer, which prevented harmful UV rays from reaching the Earth's surface. And scientists hypothesized that the use of these propellants was eating a hole in that layer that would emerge seasonally over the Antarctic and expand over time, causing increased skin cancer deaths around the world, as well as losses for agriculture. So the ozone layer problem is seen as a global public good. A protected ozone layer would offer a good for all people in the world, whether they contributed to or not, and that protected ozone layer wouldn't be something that we would compete with each other. Another way to think about this problem is the atmosphere is a global commons in which it's difficult to exclude people from having access to, but that the atmosphere can only handle a limited amount of pollution. We might also think of this as a harmony game in which actors have overwhelming incentives to kind of clean up their act. Given that the ozone hole appeared regionally first over the Antarctic, we might imagine that it's a regional good that has concentrated benefits for that part of the world. That's another way of thinking about this problem. Scientists played a particularly important role in this awareness of this problem, given that it is something that's difficult to observe without complex instrumentation. In fact, they hypothesized about the potential effects before they were even able to document existence of the ozone hole. And the fact that scientists had really strong, compelling evidence that this was indeed a problem helped inform decision makers that they should take action and that the stakes were quite high. The U.S. Had already passed domestic rules in the late 70s, even before the 1985 Framework Convention to address ozone was negotiated. And so the U.S. Model here is one of wanting to internationalize its own domestic legal rules, which had already sought to phase out non-essential uses of CFCs. But the fact that the Reagan administration took such a leading role on pressing for more significant reductions of these ozone depleting chemicals was not foreordained that President Reagan had to overrule some of his advisors who were less supportive of taking robust action. UNEP, under the leadership of Mustafa Tolba, is also thought of as being one of the change agents that motivated negotiations and provided a leadership role as an agenda setter of pushing this issue up the set of priorities in the international system, helping guide the negotiations to a successful close. He has memoirs and other documents that express the role that Mustafa Tolba, played in this process, and UNEP is generally regarded as having quite a successful, role in ensuring that these negotiations were brought to a successful close. So the sequence that you see over the ozone hole is the Vienna Convention in 1985, which is a framework convention, and then subsequent protocols with more specific targets and timetables, starting with the 1987 Montreal Protocol that then add more chemicals and hasten and deepen the phase out of various ozone depleting chemicals, starting with chlorofluorocarbons, then adding halons, and then carbon tetrachloride, methylchloroform, later adding HCFCs and methyl bromide. And so this gradual expansion, hastened timetable, and deeper cuts was facilitated by this process that started with the Framework Convention in 1985 and went through subsequent amendments and protocols, which we'll talk more about in a second. There were particular inducements to secure the participation of developing countries in this agreement. There was a 10-year phase-in of obligations, and there was also a separate fund that was created that wasn't under the World Bank, that had its own secretariat in Canada, that was intended to pay for the incremental costs of what it would cost developing countries to move away from these chemicals. And there were also import-export restrictions so that countries that weren't party to the agreement wouldn't be able to import any of these chemicals. The multilateral fund to help address developing countries' efforts to move away from ozone-depleting chemicals had an executive committee which had half of its 14-member membership from developing countries and half from developed countries. So this executive committee structure brought buy-in from both developed and developing countries. And since 1991 up through 2024, it's approved more than $4.2 billion in projects, much of them, or at least more than half of them, in the Asia Pacific. But this amount of money is quite small relative to what we see as necessary to address the problem of climate change, which we'll talk more about next week. I mentioned that there were efforts to amend and modify the ozone treaty arrangements, and there was a perhaps unique structure built into these arrangements that allowed minor refinements, say in the timetable for phasing chemicals out, to be done through majority rule and then later modified to be 2/3 vote of the parties to the convention. And so that was ultimately binding on those who didn't sign on to those new adjustments. More complex changes, like adding new substances, required ratification by a 2/3 majority before countries were bound. And so this differentiation between adjustments on the one hand and changes on the other created a process that allowed for more flexible updates to the agreement, allowing for minor changes to be changed in the context of the meeting of the parties without countries having to go home and ratify the agreement to home audiences, which, for example, in the US case could be quite challenging. And so this flexible nature of the rules allowed for scientific information to inform the proceedings, and as scientific evidence came forward suggesting that a swifter phase out of some chemicals would be required to address the problem, those were enabled by the structure of the rules of the regime. The use of ozone depleting chemicals has declined dramatically, with more than a 90% decline for most of these chemicals, and the ozone hole has already started to close. There's the projections that by 2060 that it will be back to what it was in 1980. And for the US alone, the action taken to address ozone depletion may avoid more than 440 million cancers, more than 2.3 million deaths from skin cancer, and perhaps preventing as many as 63 million incidents of cataracts. So these are huge effects that the efforts to address ozone were able to achieve. And one reason why it was so successful is that the nature of the problem was amenable to solution, that the chemicals that were used in refrigeration and aerosols were important, but they weren't central to modern life in the same way that, say, fossil fuels are for heating and lighting and transportation. You also had private sector buy-in with companies like DuPont, which were responsible for a large share of these chemicals already having developed substitutes at the time of the negotiations, and they could see that their own future was likely to be profitable with the substitutes that they'd already developed. You also had the ability to revise the timetable with the voting rules, which provided some flexibility to speed up as time progressed. You also had measures to encourage participation of developing countries with the phase-in rule, with the fund, and trade sanctions for non-parties. A slightly different perspective on the success of the ozone treaty arrangements was provided by Nina Kelsey, who talked about the success of the treaty over time and relative to other issue areas. And she talked about the institutional design of flexible multi-round negotiations that allowed for changes, which we've talked about, the role of knowledge creation and epistemic communities in developing sound science that informed participants' sense of what was required, just basic issue characteristics that the other issue areas like climate are simply harder, and that in this space there was already maturity of technological alternatives. And that there were concentrated benefits and maybe diffuse costs for wider system. And so that there were a number of key companies and key countries that stood to benefit from, like the United States, that stood to benefit from action to address this problem. And then there were more idiosyncratic characteristics like leadership of the United States and Mustafa Tolba at UNEP. But as we think about the success over time, that question, she speaks of a green spiral, where that the ongoing negotiations changed the interests of the participants, particularly of states and private sector actors, that made them more favorable to regulation over time, because as they invested in alternative infrastructure to prepare new alternatives, then they saw that their interest had shifted to more regulation and more stringent rules that then they hoped others would have to live by. And so as those sunk costs of investments were made, that expanded their sense of what regulation could deliver and was desirable to create a profitable future for them. And so you had this green spiral that each successive wave of investment facilitated a willingness to make deeper commitments over time. There are policy implications that flow from this, in that you want to think about how to generate iterative improvements over time, and so that you don't get locked into an incremental first step improvement, but one that facilitates constant process improvements that allows for even more robust environmental protection over time. So that's one policy implication. The other is that policies could generate vested interest in that incremental step. So think about the role of natural gas as a bridge technology in the energy transition, and previous climate negotiations have created space to move away from coal towards natural gas, but that may lock in the level of improvement around that new support for natural gas, which impedes further progress to move beyond natural gas. So how do you develop a negotiating and international process that facilitates improvement beyond that incremental first step? The other idea that comes out of this work is are there high points of leverage where interests could be convertible, in that DuPont, for example, was developing alternatives to the chlorofluorocarbons, and was there a way that if those actors could shift their interest to support regulation, that would have an appreciable impact on the problem? So are there points of high leverage that allow you to make significant progress? And so can you identify those potential leverage points in advance?